Hi everyone, it's Dr. Huizinga, and I wanted to create a short lesson here before we move into this next section of the course. This next section of the course is a section on deductive logic, and so the work that we'll be doing here is fundamentally different than the work we have done in the other chapters, in the other sections of our course. And so I wanted to pause here and give you some indication of what this will look like and why we're doing this. So if you'll indulge me for a few minutes, I'd like to just cover that with you. It's important stuff to get your mind around what it is precisely that we're doing before we actually engage in doing it, and so that's what this lesson is about. The content in chapter 10 is we're dealing in this section, whether it's chapter 10 or some other chapter, with deductive logic, deductive arguments. If you'll recall, in the beginning of the course, the first thing that we looked at, one of the first distinctions we made, we noted that there are two kinds of arguments. There are arguments whose premises are intended to guarantee its conclusion, and arguments whose premises are intended to make a conclusion more likely to be true. The second one, the latter one, where the premises of an argument are intended to make the conclusion likely to be true, but perhaps not guarantee it, is called an inductive argument. Well, the other kind, and we've already spent some time in the other lessons, in prior areas of this course, looking at the at inductive reasoning. Okay. Now we're turning our attention exclusively to deductive reasoning. We're turning our attention to arguments in which the premises are they're intended to guarantee their conclusion. So, and because you've already been through chapters 1 and 2, my assumption is that you're pretty clear about what I say when I'm saying that. If you're not, I strongly recommend that you go back and just review from the initial lessons in this course the difference between deductive and inductive reasoning. But this section of the course is going to deal exclusively with deductive reasoning. Now, notice that what you'll find, and what many of my students find in this section of the course, is that deductive logic, what we're going to be doing in this section, they find it a lot easier than the work that we have done in the prior sections. Here's why. The work that we've done in the prior sections is largely conceptual. And what I mean when I say that, it's not as though there isn't conceptual work going on in this section of the course, but what I mean when I say that it's largely conceptual is something like this. It's generally definitions that we're giving to ideas that occur in the real world, or as part of how we make sense of the real world, and you're asked in this course to learn those definitions and essentially apply them and see them in the world. That's well and good. It's difficult to do that, though, and as many of you have found out, there's a difference between maybe memorizing the definition of, for example, a fallacy, and actually being able to see an instance of that fallacy in the real world. Just understanding the definition doesn't give us some obvious recognition of it in the real world. That second phase requires a deeper level of understanding. The work in this section is unlike that. It's unlike the definition application work that we've been doing before. In this regard, the section that we're working on now is a lot more like a math class. I almost said like a deductive logic class, which it is, so that would have been obvious, right? No, it's actually more like a math class. And what I mean when I say that is, in math, you don't worry about, um, well, you do worry about definitions, but mastering math is about mastering um, procedures. And as long as you can follow the procedures and the steps for solving the problems, there is a clear, correct answer that you should be able to derive. This section of the course is like that. We deal with symbols and operators in the same way that math deals with symbols, numbers, and operators like multiplication, division, subtraction, square root, these sorts of things. So a formal logic is a lot more like math than it has been anything else that we've covered. So I wanted you to be clear about that. Now, why would we study this? Well, formal logic is really important for how we understand language. All languages have a formal logic aspect to them, including, by the way, computer languages. What we are studying in this section of the course is really the foundation for binary code and computer coding of any form. Actually, from the work when I was in graduate school and I started really taking my first hardcore deductive logic classes, what I found is that it was actually conceptually very easy for me to move from that to computer programming languages and understanding fundamentally what was going on there. I initially started learning coding languages by goofing off in Microsoft Excel and creating elaborate codes in Microsoft Excel to do different programs automatically and to find and execute certain functions. All of that and all of the logic of binary systems comes out of and is actually a product of deductive logic, as we will be studying it here. It also helps us understand when we study deductive logic, we begin to see arguments in a different way. We begin to see the arguments that others make to us, the arguments that we make ourselves. We're able to see more clearly their structure or their form, the pattern of someone's reasoning. And this is really what I'm hoping that you will begin to be able to do in this section of the course. That is, to be able to learn to recognize the structure of people's reasoning, including your own. Now, when I say that, keep in mind that we're talking here only about deductive arguments, arguments in which the premises are intended to guarantee their conclusion. So the driving question for us in this section is going to be, when somebody gives me an argument, do their premises guarantee their conclusion? Now, whether or not, sorry, I was looking at my notes to make sure I'm covering the points I had originally written in my notes, and it turns out I'm not, but it's still a good lesson, so we're just going to roll with it. Whether or not, and this is an important point, so I want you to really focus on what I'm saying right now. I want you to conceive of it. Remember that the difference between inductive and deductive reasoning was this. With an inductive argument, the premises are intended to make the conclusion more likely to be true. More likely. Not guaranteeing it, but more likely to be true. These were the arguments from analogy, the scientific reasoning, the hypothesis generation, all of this that we've talked about in the prior lessons, in the prior weeks. With deductive arguments, remember that the premises are intended, they're supposed to, guarantee that the conclusion is true. But now here's the trick. Whether the premises of a deductive argument guarantee the conclusion of that argument has nothing to do with the content of the argument. It has to do with the form or the structure of the argument. It doesn't matter what you're arguing about. It only matters the content of the argument. I can give you an example here, and I will in just a second, but here's what's really important from this. You must distinguish in your mind right now, early on in this lesson, in what we're going to be covering in Chapter 10, the form of an argument versus the content of the argument. That is, what we are arguing about, the things, the topics that we're talking about, whether it's politics or religion, or whether it's personal life choices, or whether it's the suitability of friends you have for different careers, or whether they're jerks or not, or whether, whatever we're thinking about. Separate the topic of conversation, separate the topic of the argument, the content of the argument, from the form of the argument, from the structure of our reasoning, how our ideas relate to one another. We will only be focusing in this section of the course on how our ideas relate to one another, irrespective of whether those ideas are irrespective of the content of those ideas. We are going to remove the content from what we're talking about, from the arguments we look at, and isolate solely and only their structure for consideration. Why? Again, because whether or not an argument is deductively valid, that is, whether or not the premises of an argument guarantee its conclusion, is a function of whether or not the structure of that argument allows that to happen. It has nothing to do with the content of an argument. Whether the premises of an argument guarantee its conclusion has nothing to do with the content of the argument. It has only to do with the form of the argument. So if you'll allow me, if you'll indulge me, I have an argument for you, or an example of that for you. Consider the following argument. If something is an A, then it's a B. That thing over there is an A, so that thing over there is also a B. Now, what's an A? What's a B? We have no idea. We don't know what an A is, and we don't know what a B is. What we are told is, first, if it's an A, then it's also a B. And then we're told that that thing over there is an A. Now, if everything that is an A is also a B, and that thing over there is an A, notice that your mind tells you that that thing over there must also be a B. Why? Because every A is a B, and that thing is an A. So it must be a B. Notice that there's no content in that, yet your mind recognizes that that is a good structure of reasoning, that the ideas relate properly there, such that if those premises are true, if every A is also a B and that thing over there is an A, then by logic, the conclusion is that thing over there must also be a B. Doesn't matter what A, B, and C are. We don't have any C's, so that doesn't matter. Doesn't matter what A and B are. What matters is how they relate. I'll give you another one. Either A or B. Either A is true or B is true. Now, B is not true, so A must be true. Now, again, I don't know what A is. I don't know what B is. But what I know is, whatever the content of A or B, that argument works. If those premises are true, then that conclusion will have to be true. And we can test it by putting in content. Either something is a human being or it's not. That thing is not a human being. Actually, that doesn't work. Yeah, it does. Either it's a human being or it's not, right? Either A or B. well, that's A or not A, so I should do something else. Either the dog is friendly or the dog is brown. The dog's not brown, so the dog must be friendly. Now some of you are going, why can't the dog be both brown and friendly? The dog can. But here's what I know. If the dog is either brown or friendly, a brown dog, I don't know what the relationship between the two is, but if a dog is either brown or friendly, and we know that this particular dog is not friendly, and we know that it either has to be friendly or brown, it's not friendly, then it must be brown. If that premise is true, that it's either brown or friendly, and if it's true that it's not friendly, then it must be true that it's brown. Okay, hopefully that made some semblance of sense. The thing to take from this lesson and what we're doing here is that we're focusing on the content of arguments, not their structure. And what we're doing here is to isolate that structure, and that's the work that we will be doing in the coming sections.